All right, guys, welcome back. So yesterday I introduced you to the real number system. This is going to take a lot of practice, so we're going to do some more of it today and probably a lot more next week. I think it's going to be really helpful if you copy down this Venn diagram that you see in front of you to refer to when you're doing the quizzes game and other activities with these. All right, so we're talking about the real number system. The first numbers we're going to talk about are the natural numbers. So they're the furthest ones in here. Those are your positive whole numbers, like 1 or 2, 3, etc. Now the next rung here is your whole numbers. Those are numbers like 0, 1, 2. So pretty much the same as your natural numbers, but these also are going to include 0. Okay, so the only difference between whole and natural is that they're 0. Now integers, these are negative and positive whole numbers. So things like -4, +2. Those are integers. Integers can be negative or positive, but they must be whole numbers. They can't be fractions or decimals. Now our rational numbers, that's where our fractions and our decimals come in. Rational numbers are fractions, like 1/2. They are also decimals that either end or repeat. So decimals like 0.4, or ones that repeat, like 0.3 repeating. Now also included in rational numbers is anything that's inside of it. So a natural number is also a rational number. A whole number is also a rational number. An integer is also a rational. So the Venn diagram sort of works is if you have an integer, it's an integer and it's a rational number. And we'll go over a few examples of that in a minute. Now, anything in this big circle here is also considered a real number. Now, there are a few exceptions to our rational numbers, which are over here in our irrational numbers. These are numbers that do not stop and do not repeat. So big, long decimals that go on forever and ever without repeating. I think yesterday I told you the most famous example of this is pi, 3.14159.265, and it just keeps on going without stopping. This is also where you're going to see some of our square roots from last unit. So something like square root of 10. If you were to put that into your calculator, you would get a big, long decimal that does not end and does not repeat. All right, so let me just think of a few examples here and see if we can place them appropriately in our real number system. So I'm going to start with something like -6. Okay, -6 is a negative number and it's a whole number. So that's going to be in our integer section. Now, if it's an integer, we also have to remember that that makes it a rational number, and it's going to be a real number as well. Notice -6 cannot be considered whole because it's a negative number. All right, let's try another example. How about the number 0? So 0 is a whole number. Not a natural number because the natural numbers don't include 0, but it is a whole number. And if it's a whole number, it's automatically going to be an integer and it's going to be a rational number. It's also going to be considered a real number. All right, let's do one more example here. 0.75. This is a decimal that ends. Anytime you have a decimal, that's going to be a rational number. Decimal that ends 0.75, so it's a rational number, and it's real. Because it's a decimal, it's none of these other things. It's not an integer, it's not a whole number, it's not a natural number. Okay? Next week, we'll talk about some more examples of where you'll find irrational numbers and where those are going to fit in. But try and keep this Venn diagram in front of you and use it to help you on the quizzes games. All right, If you have any questions, just shoot me a message. I'd be happy to help you out.